Hi everyone, this is lesson 711 to 715 on quadrilaterals, part 2. On the last lesson, on part 1, we went over quadrilaterals, definitions, and what they look like. Here's a reminder of that stuff that we went over last time. So here are the definitions in case you just need a quick reminder of those. Again, this is just taken from our book. We're going to be using these definitions moving forward. So something you definitely should be able to do is tell me what the definitions are of these shapes. So this is a good test question, a very simple test question. I could just ask you to maybe even match definitions with their names. So imagine you had a list of all the quadrilaterals and you have a list of all the definitions. Would you be able to arrange them or match them up properly? So ideally, you should be able to write this. We have had this on a test before where you actually have to write out the definition. So that could be something that comes up on our next individual test. All right, so that's you don't necessarily have to copy that down again. If you didn't copy it down last time, for sure this would be a good time to do that, because obviously if you could use your notes during a test, it'd be nice to be able to look this up and have the book's definition instead of something that you might find online. All right, in addition to that, I gave you a little bit of a visual. On here, I try to combine the two pictures I gave you before. And so here's the umbrella picture that a lot of you responded and said you liked. It helped to organize it. So I've tried to put the actual images of those shapes right next to it, so you have a good picture of that and where they go. So quadrilateral only has 4 sides, no parallel lines, no congruent sides. So it looks a little bit deformed. It could look very similar to a kite, except the kite is where we actually start to see we have congruent sides. So 2 pairs of consecutive congruent sides. This is where it starts to form some solid structure. Now I had a couple people ask about a kite last time. This is definitely a shape that does not have any parallel lines, so no parallel lines. It's kind of falls into its own category. Everything else has parallel lines. So you either have 1 or you have 2 pair. So trapezoid, anything that has a trapezoid name on it, has at least one pair of parallel sides. According to our book's definition, technically everything over here could be considered a trapezoid. But traditionally, really if it has 1, we call it a trapezoid. All these have 2, so if it has 2, it's considered a parallelogram. More specifically, if it has right angles, it's a rectangle. If it has all sides the same, it's a rhombus. And if it has all those qualities, it's a square. So square is probably the most perfect quadrilateral. Has a lot more properties than everything else. So it really combines all the properties or characteristics of all the other shapes. All right, so if you need a good visual of that, or I don't know if you need to copy that down again. Hopefully you have this in your notes. Take a picture of that or a screenshot of that and then save that for your files. All right, so we're going to move on. So we definitely need to know how to draw these shapes, and we need to know not just about their sides and angles, but about these imaginary lines that you don't see in these pictures, and those are the diagonals. All right, so we're going to explore the diagonals of quadrilaterals. I actually have a worksheet for you. Well, I'm going to attach it online for you. If you're able to download it and possibly print it out, that might help you out. Otherwise, all you really need is graph paper. Could help you just fine. Nothing special about the handout. So I've taken one piece of it, and I'm just going to talk about this for a second, and then I'll go to a page where I actually have 8 different quadrilaterals on it. So this is really just to explain what the handout is going to have. So for every shape, you're going to have, well, obviously there's the name. So the question is, do you know how to draw it? So let's draw a picture of it. And can you tell me a few things about it? So we're looking for true or false statements. So in the end, we're hoping to either put a T or an F in these. Are these true statements or are they false statements? And so all of them have to do with the diagonals. All of them are about the diagonals. So what's different is the first one's asking, are they equal in length? Which means, are they congruent? Are they the same length? However you want to phrase it, we're going to be looking at their diagonals, and hopefully we could tell whether they're the same or not. The second one asks about the diagonals bisecting each other. So bisect, in case you don't know the word bisect, it really comes from 2 words. First is the prefix bi, which means 2, and sect, the end of that word, really is short for section. So if you're familiar with the word section, right? So it's like 2 sections. Do they cut each other into 2 equal halves, into 2 sections? So a lot of times when we say, oh yeah, they got cut in half, that doesn't mean they get cut into 2 pieces. It means when they say cut in half means they're actually the same size, right? So 2 equal halves. And the third is, are the diagonals perpendicular? So if you don't remember what perpendicular means, perpendicular is where 2 lines, usually we see a picture like this, where 2 lines touch or cross, and we have a 90-degree angle. So when they intersect, do they form a right angle or 90 degrees? Right? So that's what we're looking for. It doesn't matter if they cross each other like this, or if they just touch each other, that's considered perpendicular. So even if I draw it on the side like this, is it perpendicular? So that's what we're looking for in all these shapes. So I'm going to go through all 8 of these, and I'm going to show you really how to draw these. And then after we're done with the drawings, then we'll talk about the true and false statements. So I'm not going to draw the picture on this one because I already have it drawn out on the next slide. All right. So here is, this is a blank version of it. So this is the worksheet I'm going to try to make available for you, for those of you that can print it out. If not, really you don't need to anyways. If you have graph paper, it makes it easier for you because the grid definitely helps. But this is, I'm just showing you a blank version of this so that you can have an idea what your notes are going to look like. So there's a total of 8 shapes. The only one that's not on here is quadrilateral, right? The bigger umbrella. All right, so let's go into these. Here's one that's all filled out with the drawings, and I'll zoom in to each one for a little bit. If at any point you need to pause it because you're copying down the picture, then do so. And I would recommend that you draw it out exactly as I have it. It'll just make your notes a lot easier to follow. I've intentionally drawn them a certain way to make it easier to understand. And if you don't have graph paper, do your best to pretend you have graph paper. But I would strongly recommend you get some, or if you can, print out a copy of this handout, and it'll make it easier for you. Or maybe you could download it on your phone or iPad or something like that, and then you could just write on this. All right, so I've put the definitions as you're copying this down or drawing out your shape. I've put the definitions there as well, just so we could have them. If you could, it's kind of looks a little bit sloppy, but hopefully you can read that. So a kite is a quadrilateral with two distinct pairs of consecutive congruent sides. Okay, so in these drawings, on all these drawings, you'll notice that I have put markings on the diagram that reflect the definition. So this is similar to the ones I drew before in the notes. So the double marking tells me these two sides at the top are congruent, and this triple marking tells me these two sides at the bottom are congruent. All right, so I've also drawn in some extra lines, and these are what we call the diagonals. So the lines that go from vertex to vertex, we call these. So when we connect them, they create these lines, and we call them diagonals, and we want to know how do they interact with each other. So that's where those three questions come in. Are they equal to each other? Do they bisect each other? And are they perpendicular? Now, if you look at my drawings, I kind of already put the markings to kind of give you a hint. So you could answer these. I'm not going to give you the answers now. We'll come back to them later. If not in these notes, maybe in the next part 3 of our quadrilateral notes. All right, so the diagonals are equal in length. Look to see if you think these diagonals are the same length. And this, when we talk about true and false, these are, is it always true? Is it always true or not, right? So it has to be true all the time. It is possible, I think you could draw this so it looks like the diagonals are equal in length, but if I just count, this is what, 1, 2, 3, 4, 5, 6, 7, 8. This diagonal has a length of 8, and the one that goes across has a length of 6. All right, so they're not going to be equal in length. So I'll just to give you an idea of how you can answer those. Bisect would mean that they cut each other into equal parts. Well, here, this is 3, and this is 3. So the reality is these two pieces are the same. But it says bisect each other, which means both pairs have to be cut into equal halves. So here's one line got cut into 2 equal pieces. But when I look at the line that goes up and down, this one has a measurement of 3, and then this one has a measurement of 5. So these two pieces are not the same length. So they do not bisect each other. Only one of them gets bisected. So that one, I'll put those markings to show that those two are the same length. All right, so I'm going to go on to the next shapes, and then I'll kind of show you more now that you kind of get an idea of what we're doing. And so here are the first 4. So here's half of the worksheet. The first one, or the second one, is our trapezoid, which has one pair of parallel sides. So you'll notice I've included the arrows to kind of tell me that's how I know it's a trapezoid. I would also, again, try to make sure you draw this one out the same. Look at the key points here and how far away they are from each other when you draw this out. You do not want to draw your trapezoid. Common mistake, if I didn't already mention this, I think probably when you first learned about shapes and you learned about a trapezoid, The first trapezoid you probably saw looked like an isosceles trapezoid. That's the most common. That's the most pleasant to look at. That's the easiest to teach. All right, but we're at the point where we could tell the difference between one trapezoid and another. So a trapezoid doesn't necessarily have that nice symmetry, right? So it only has a parallel line. So this one I've tried to draw it in a way so it doesn't look like an isosceles. Compared to the isosceles, where I try to make sure these two sides were the same length, right? And then in the right trapezoid, you'll notice the right angles on the left. So a trapezoid with two right angles is our definition for a right trapezoid. So those are our three trapezoids. They all have one pair of parallel sides. I've drawn in the diagonals for you. Make sure you draw in the diagonals. If it helps, use colors. I think it helps to draw them a different color so that way you don't confuse them with the actual shape. And let's see. If you need more time to copy this down, then this would probably be a good time to pause. So that way I could just go through and show you the rest, right? Because right now you're just copying down information. All right. So in addition to our trapezoids, we have everything that's considered a parallelogram, right? So, all right, I guess I'll just show you the next two for those people that didn't pause it but are still copying the others. All right, so the parallelogram has two pairs. Anything that's considered parallelogram has two pairs of parallel sides. So you should notice the notation with the arrows. I think I mentioned that before in the other notes. Arrows, matching arrows mean parallel lines. So since there's two pairs, we use a single arrow and then a double arrow just so we could tell them apart. And so hopefully you notice in all these pictures how the diagonals look. Compared to trapezoid, parallelogram, you should start to see how they're interacting with each other. So I've actually included the markings on here to let you know, right? I've included some markings here, kind of giving you a hint of what's happening with those diagonals. So I'll see if you remember what those markings mean. Now, the parallelogram and the rhombus look very similar. They are really look like siblings, right? So in some cases, they could be very hard to tell apart. The main difference is the parallelogram traditionally looks a bit stretched out, right? So definitely one pair of sides is longer than the other pair of sides. So make sure when you draw that out, you make sure it looks very clear that those are different lengths. With the rhombus, these are the same length, right? So if you draw these, put these in the exact same points that I place them, then these sides should end up being the same measurements. So all four sides are equal to each other. So that's why I have this marking, the same tick mark, we call them tick marks, are the same. So you'll notice what changed with the diagonals, right? So was there any change with how those diagonals intersect, right? So see if you notice the difference in the drawing. And the last two are the rectangle and square, which are also under that parallelogram umbrella, except rectangle and square, instead of being slanted like the parallelogram and rhombus, are standing straight up. They're perpendicular. The sides are perpendicular. They have 90 degrees. So rectangle has, by definition, says it has 4 right angles. And a square has those same properties plus the properties of a rhombus to give us 4 right angles and 4 equal sides. So make a note of the tick marks that I put on the diagonals. Those are kind of big hints as to how to answer the true and false questions. So I think I've pretty much given you the answers in the picture. So hopefully you could answer those on your paper. All right, I've given, I think that's about it. Now we're going to be talking about, well, we just finished talking really about like the diagonals and how they intersect. I'm showing you pictures of it so you could kind of notice how they relate to each other. Typically, I'll go through like a slideshow that we kind of visually show how all these diagonals relate to each other, but that would probably be like another 15-20 minutes. So I'm hoping that just by showing you these pictures, it kind of makes sense. And with the tick marks, hopefully that kind of explains the answers to the true and false. All right, so at this time, I'm going to say hopefully you have all 8 done. Hopefully you've paused it. So there are the first 4. If you're still copying those down, again, pause it, copy them down. And then hopefully if you're done with those, and then here's again the last 4, hopefully you have all those copied down. Okay, so the last thing I want us to do is really just answer these questions, these true and false. So that way you have everything complete. Ideally, you have everything copied down at this point. Hopefully you've answered all the true and false. If you haven't, then I would say pause the video now. See if you could go through and answer all these in pencil, and then that way you could see if you got it right or wrong. And then I'm going to go through and give you the answers to all these. We'll talk about the solutions. All right, so for kites, we're looking at diagonals are perpendicular, right? So that was kind of a big hint. There's a 90-degree angle there. That was the hint that these were perpendicular. We said they don't bisect each other, but one of them actually bisects the other. So that's the only thing that's true about it. So it's like a half-truth, but the only one that's completely always true is the diagonals are perpendicular. All right, and for the trapezoid, none of this is true. Diagonals are not equal in length, so hopefully you could look at these. Hopefully it's a little bit obvious. I tried to draw it in a way so it looked like one was completely longer than the other. It might not be so obvious. Trapezoid's a little bit hard to tell depending on how you draw it. They don't bisect each other. You'll notice there's a small piece and a long piece. Right? There's a small piece and a long piece. Those are not cut in half, right? That doesn't. And the other one maybe you might have got wrong is the diagonals are perpendicular. So the best way to check to see if they are perpendicular, let me find, I have a little square somewhere I put. Let me copy this one. So, all right, so the best way to tell if something is perpendicular is to use a shape that you know has a right angle. So like a rectangle or a square. So if I actually put this 90-degree angle in that intersection, you should notice it's not 90 degrees, right? I could even put it on this end, right? You know that corner is 90 degrees, and there's still this extra space. So that tells me that that's not 90 degrees. So even if you saw this on a screen and you needed to test it out yourself, grab a piece of paper, something with a corner, an index card, and just put it on the screen, and you could test it out that way, assuming it's drawn to scale. All right. Oops. Let's do. Oops. All right. And then right trapezoid. Here's our right trapezoid. Carry this around. All right. Nothing again is true either. And so we see that there's a small piece and a big piece, and the diagonals are not being cut in half. They do not look the same length. This one looks super long. This one looks a little bit shorter. And then the 90 degrees, if I rotate this, maybe something like that. So yeah, that doesn't make sense. So if I put it here, that does not look like a 90-degree angle. All right. So, and if we look at isosceles trapezoid, here we actually have a true. So we have the diagonals are equal in length, but it's still not 90 degrees. So it's still not perpendicular, and they do not bisect each other. So this one, a lot of times people will think they bisect each other because they're equal in length, because it just looks nice. But remember, bisect means how they get split. So in this case, they're not the same size. So we cannot say they bisect each other. So that's a false. All right. And let me take this. And we have our parallelogram. So diagonals are equal in length. Nope. This one, most common error, this has actually been on a test, and most people will say that they are equal in length. Just the way it looks, sometimes if you look at it quickly, you're like, yeah, those look like the same length. But these two, this one is actually longer than this one. Right, so be careful there. But they do bisect each other, so that's why we have these markings, right? So even though they're not the same length, they do cut each other into two, both diagonals cut each other into two equal parts, right? Now all four of them don't have to be the same length, right? Just the ones on the same diagonal have to be cut in half. And it doesn't look like it's perpendicular. I could test that one out for you as well. Let's see. Yep. So that is bigger than 90 degrees, right? So definitely that's bigger than 90 degrees, and that one's smaller. So that parallelogram is not perpendicular. When we get to the rhombus, you'll notice as soon as we make all the sides the same, now we have, not only do the diagonals bisect each other, but now we have 90 degrees, right? It actually fits nicely in there. So here, that's a good way of proving that that is perpendicular. So that's why it's true. All right. And then let's see if we go to rectangle number 7, and diagonals are equal in length. So hopefully that looks a little bit more obvious that these are the same length. Right now, more than the parallelogram. Diagonals bisect each other. So there we have, not only do they bisect each other, but actually all 4 of these are equal. Right? Since they are the same length, they all get cut. So a little side note, that means we have some triangles. If you didn't notice, we have some triangles that are congruent, top and bottom. And there's 2 other triangles, left and right, that are congruent. And all of them are isosceles triangles. Right, so there's a lot of other stuff that's being created here. I'm not going into like every single detail because there's just a lot we could talk about. Vertical angles being congruent. We could prove certain triangles are congruent. So keep this in mind. As soon as we add diagonals, we start to create triangles all over the place. And then everything you know about triangles, we could start to use to solve for missing parts, right? So, all right. And the last one is our square. And this is the only one that has true for everything. Diagonals are equal in length. Awesome. Diagonals bisect each other. Awesome. Just like the rectangle. And diagonals are perpendicular, just like the rhombus. So if I put this in here, you'll notice, again, right angles, right? 4 right angles in the center. And just like I talked about before, you'll notice these triangles, and this is going to come up later in another chapter, that all 4 of these triangles are right triangles, and they're all the same size, right? They're all congruent, 4 congruent triangles. That's going to help us a lot moving forward in another area. All right, so those are, hopefully you got all the answers down. I'll scroll back up for a second in case you missed anything. So we have kites only had perpendicular diagonals. Trapezoid was nothing was true. Right trapezoid, nothing was true. Isosceles trapezoid, finally we got diagonals with equal length. So that was the only one that really had anything. So far only kite had 1 true, and isosceles trapezoid has 1 true. Parallelogram only has 1 true, right? I didn't notice that before. And then not until we got to the rhombus did we have 2 things that were true. And then the rectangle has 2 things that are true, but 2 different things. Wow, I never noticed that before. And then now the square is the only one that has everything true. So everything about the diagonals, all these 3 things, are they equal in length? Do they bisect each other? Are they perpendicular? You need to know for all 8 of these shapes. So take some time to study this, memorize it to some degree, try to find an easy way to remember all this stuff, right? Definitely as much as possible. All right, we'll stop it there, and I think everything else we'll do more in part 3. I think we'll have a part 3 to these lessons. All right, thanks.